Years back, we started working on the performance for our landing page. And one remarkable discovery we made was it's pretty difficult. There's no straightforward way. There are indicators, but there's no do this and your performance is improved. I can explain that in meme than words. So it's kind of like this, where you start with Lighthouse, but then you still have to understand the concepts and what is loading, what is not loading, when are things loading. So there are a few more things that you have to understand more than Lighthouse and the tools that we use. Performance issues are like any other bugs. It's, let's say you have a bug in your code. First thing you would do is debug. Like normal people would put console logs, weird people put breakpoints, but essentially how to debug. So that's my talk. We're going to debug. We're going to learn how to debug the performance issues. This is like step 0 of solving the performance issues. Before I start, I want to talk about how websites load. You type in the URL in your browser. The first thing that happens is your domain will resolve to an IP address. So there's DNS lookup, connections, SSL, and a few more steps. I'm not going to details of this, but it's mostly the connecting to the domain part. Then your index HTML is requested. So the browser will request for the index HTML. The dark blue part is the part where your browser starts loading the HTML, starts executing the HTML, or passing the HTML. When it's passing the HTML, it will come across your link rel style sheet. And that's when your style sheet will start loading. Apur, in a talk before me, talked about how CSS is render blocking. And that's why we don't see anything on your screen until this point. And after this, you'll probably start seeing some layout and some paint on your browser. This diagram is probably going to be the most important one. This is something that we're going to talk about a lot. You'll probably see this in my every slide from now. And we call this diagram as something called as network waterfall. It's a waterfall of requests that happen when you're loading the website. Let's see what are some red flags in the network waterfall. So one is when let's say you're loading a CSR app. With CSR app, what happens is you initially just load the div root, you load the empty root, and then you start loading the JavaScript. And then the JavaScript goes and adds things to your HTML. So initial HTML doesn't really have the information on what all the website has, but the JavaScript has that information. So you see this network waterfall where the JavaScript is now deciding when your site is loading. This can go bad pretty quickly. For example, let's say you're lazy loading that CSR application, then your homepage.js is loaded by the index.js, and your actual paint is happening after the homepage.js. That is about JavaScript. Let's talk about images. So we load the index.html, JS, and your JS has, let's say, the image. In this case, you will see things on your screen. So you are seeing that middle stage where it's an empty content, but it doesn't have an image. And eventually, it loads the image. The first marker is FCP. Again, something that Apu talked about. So I'm not going to details of the definitions of FCP, but it's essentially the first time the content is painted on your screen. The second point is LCP. That's when the largest content on the page is being loaded. In this case, the largest content is the image. We talked about JavaScript. We talked about images. Let's talk about fonts. With fonts, let's say you're loading with Google Fonts or any third-party font library. What will happen is your HTML, in your HTML, you're probably putting this link rel style sheet to the Google's fonts.css. So it will load the Google's font.css first, and then it'll load the actual font. Here you're seeing this purple line, which we talked about how it's a DNS lookup or connecting to domain part. You're loading third-party libraries, so it has to connect to this third-party domain. It's a new domain for your browser. It doesn't know what this domain is. So you see this extra additional time in between where you have to connect to the domain before you actually start loading the site, start loading the CSS files or font files. So this is another network waterfall red flag that you can see with Google Fonts. And yeah, it's our demo time. So what we'll do is, I just showed you how there's a network waterfall red flags with JavaScript, with an image, and with fonts. We'll go and try to fix these and see how it works. So first thing I showed was how in CSR, your rendering is happening after the JS loads. So let's see that once in code. So in Chrome, you have this performance tab, which is probably a tab that you would want to use a lot when you're trying to debug something or trying to figure out what is wrong. Here you get this reload button, so you can go and reload the site, and it will record the network waterfall and all the other things. First thing I want to do is just slow down my network a bit so that it's more distinct to see. Fast 3G is usually a good good on speed to test things out. So I'll just go and reload this page, and we'll see how the network waterfall looks like. Now, here you see that this first part is the HTML. That's when the HTML is loading. Like I showed in the diagram, this first thing is HTML. Then you see a few other things loading. The thing that I want to show first is if you see a lot of the code is actually loading after this JavaScript part. For example, this hero image, this image, is loading pretty late in the waterfall because it's your JavaScript that knows what this image is, but your actual source code, if you go to an actual view source, your hero PNG or your style sheets are there, but your hero image or a lot of your HTML content is not really here, so your browser doesn't know what to load. So it's kind of relying on this client.tsx file, which eventually goes and loads the images. So you see that waterfall with the CSR. Let's actually fix that. I kind of have this setup where I just have this flag where I can turn this into true, and it will be an SSR. So I'm not going to explain the setup, but we'll just see how what difference we see in the network waterfall. Yeah, I'm just reloading again. This is a SSR website now, so we'll see what difference we see in the network waterfall. Now, if you see, like last time, a lot of your content was relying on JavaScript to eventually load. But now, you see these things shifted this side. And if you look at the view source, you see all the content is here. So if I look for hero PNG in this, you'll see that hero PNG is actually being loaded. So your browser can actually go and figure out that it wants to load hero PNG first, and it will go and make that request, and things will load faster. So this is about fixing the JS parts. Let's actually fix the image parts as well. In this, you're probably seeing that this image is still loading fairly late. Like, this is an important image. We want to show that first. This is an important thing for user. So it should load a bit earlier as well, right? What I can do is, if I go to my code, here you're seeing this loading lazy thing. This is the issue we faced at razorpay.com as well, where we had one common image component, and it had loading lazy as default. And a lot of time, it just ended up lazy loading the hero image. What we'll do is, first, we'll just remove this loading lazy. Another thing that we can do is, because we know that it's an important image, we can also start preloading it. So it'll be one of the first things that start loading. Now let's try this and reload. Now if you see, the hero image is loading pretty fast. It's almost loading as immediately as the HTML is there. So if you see, your LCP also gets closer because your hero image is now loading earlier, and FCP almost got fixed because of the CSR change that we made for JavaScript. Another thing was fonts. We talked about how when you're loading a third-party font, it just creates this network waterfall where you're calling a third-party domain, it's calling the font file. So let's try and fix the fonts. If you go to Google Fonts, In this web, you'll see that there are these two extra things called pre-connects. There is obviously this link style sheet, which is for styling, but there's also pre-connect that Google usually recommends. I had commented out this, but let's actually remove this and see how it works. One thing about pre-connections is it's kind of difficult to figure this out in this performance panel. A better tool for figuring this out is a web page speed test. So I had kind of tried this out on the actual webpage test.org, and we can see the difference once. So first one is, this one is without the pre-connect. Here, if you see, the Google Fonts file is loading. Yeah, it's this request, which is the first CSS request from Google Fonts. And then after that, you see this another request, which is going to the actual font file, which is coming from gstatic.com, the two domains that we are actually pre-connecting. Here, if you see, the connection itself starts after the Google Fonts CSS is loaded. But when you actually add those pre-connects, the difference you'd see is here, you see this font CSS loads, the Google CSS loads the way it did. But here you see this another pre-connect request, another connection request, which happens a lot earlier. It happens at the start itself. So eventually, when you're loading the font, actual font file, you don't have to pre-connect again because it's already connected at this point. So this is kind of how you can fix the font issues as well. So we saw the JS issues, the font issues, and the image issues. So let's move to next things. Next thing I want to talk about is interactions. So far, we've only talked about the loading part of performance, where how your website is loading. But another important part is how does the interactions happen? You might see yourself at such situations a lot of times where you're clicking buttons, you're hovering over things, but nothing is happening, your website is stuck. How do you fix these issues? So let's do that demo as well. So on this website, if I hover over these items, they load pretty fast. But if I hover over these payments, there's some weird laggy things that are happening. It's not pretty fast. So how do you figure out what is happening? What is the issue? So you can again go to Inspect, Performance. This time, we don't want to reload the page. We just want to test that interaction itself. So here, there's another button called Record. So you can just start recording at that point itself. Yeah, the recording started. So now we can actually hover over and see the interaction, just interact with things so that it's being recorded in the DevTools. So here we see that things are getting blocked. You can stop and just see the things. Here, you see these tasks, the blocking task, a lot of blocking tasks here. You can actually scroll down and see what is the problem. So if you scroll down, here it says that there's some function called block main thread please, which is just blocking the main thread for a lot of time. So we'll see. We'll go and find what is this function. Here I see there's some function that is being called when I'm trying to open the menu. What if I just remove this? And I can clear this, record again. Here if you see the interaction issues are fixed, it's interacting pretty fast now. And you probably wouldn't see those blocking things anymore. So if you want to figure out your interaction issues, you can actually use this main thread tab where you can see the blocking issues. Now, this is great, but realistically speaking, nobody probably has block main thread please function in their code unless they hate their jobs. So it's very, very rare that the verdict would be so easy, the issue would be so easy to find. A lot of INP issues are fairly difficult and not so obvious. What often happens is, for example, when we were working on razorpay.com, one issue that we faced was we were loading a lot of JavaScript in general. So there was no particular function that was blocking the main thread, but just the amount of JavaScript we had, which was blocking the main thread. And which is weird because razorpay.com is a static web page. It's mostly just content. It doesn't need to have JavaScript. But the way React loads is even when you're doing SSR, it will still load all the JavaScript code that you're writing in your JavaScript bundle. It won't skip that. So because of that, a lot of JavaScript was being loaded, and main thread was getting blocked. And because main thread was getting blocked, the initial interactions, when people were trying to interact with navbar while things are loading, were very laggy. And that is kind of something that we wanted to fix. Back then, Divyanshu, who was my tech lead, we kind of discussed on how we can fix that. And Divyanshu mentioned that Astro does something called selective hydration, where you can mark a certain part as just non-static and certain part as static. And that can fix the issue. And I jokingly said that if we actually end up fixing that in our code base, because it's a custom code base, it might be worth just releasing a new SSR library out of it. So drum rolls. Presenting a new framework, no, it's just React Server Components. React Server Components kind of fixes this problem where it lets you mark certain things as just static. We'll see that demo. Yeah, I built this demo at like 2 a.m. at night, so it's really just default looking application. There's no effort that I put, but yeah, this should work. So what I said was, by default, React will load even the things that are just non-static. So for example, if I go to, I'll just copy this get started by editing. This is a static part, so it's not really interactive. It doesn't need any JavaScript logically. So we'll just go and search this. There's this sources panel where you can actually see all the source code that is being loaded in your browser. You can go to top, search in all files. Pretend it was like this. You didn't see that. It was supposed to be this. Yeah, I just reload. Yeah, that didn't happen. So when you type get started and just search it on your code base, you see that there are multiple references of get started. One is the index.html part, the index part, which is obvious. It has to be in the HTML index, first index. But you also see its reference in page.tsx, which is the JavaScript file. But it shouldn't be there. It's just the static code, right? And this is still a small demo, but when you do this on your landing pages or large code bases, a lot of code is being loaded, which is not really needed for interactions. With React Server Components, I messed this, but you can skip this. And by default, Next.js will turn this into a server component. So now if I go and search this, let me just refresh. Search this again, I just see one reference, which is the index.html. There's no reference in the JavaScript parts. So what React Server Components is doing is because there's no directive mentioned, it will by default treat it as a server component, and it will just keep adding this part into a JavaScript bundle totally. So there won't be any JavaScript when you're loading this with RSC. So far, so good. We have talked about network waterfalls. We have talked about interactions. This was the title of my talk, Debugging Performance Issues of Website. But while working on it, I realized that performance is still a scoped down term. What you're essentially trying to fix is the user experience for the user. You want your user to feel good when they're loading website, to just make it look like it's loading fast. There's a term for this which deals with the user experience and performance together. It's called perceived performance. This is something that we don't talk about it often, but we'll just go through this a bit. So let's go with definition. Perceived performance is a subjective measure of website performance. In other words, how fast website seems to user. There's a difference between loading website fast versus making it look like it's loading fast. And the problem with this is it's harder to quantify. There's no tool that says that your perceived performance score is 100 or perceived performance score is 70. It's harder to measure as well. There's no direct way to say that this is a bad perceived performance and this is a good without really contextually dealing with which application you're talking about. I didn't make this up. This definition comes from MDN. MDN has a different page for perceived performance, which goes into details, so you can check that out as well. But let's see what I mean by perceived performance and what is exactly perceived performance. I have this demo where I'm loading a site. Now, if you see it, the one site loaded faster. It loaded a lot earlier, but it had this janky experience where it just feels like a lot of things are jumping around, whereas the second site is just loading straight up, and there's no jankiness in that. So in this case, the second thing is technically more performant. Although it's showing content slower, but it also has a better experience when it's trying to show the content. Let's see the other example. In dashboard, on one side, I have a loader. On the other side, I have skeleton loaders, and I'm just rendering some static things already. For example, this navigation bar that you see. This navigation bar that you see and top nav you see, it's already loaded because it might be static for a lot of you. It also has some animations. So if you look at the second one, you see things are loading with some animations, and it's giving a better user experience to consumers. So although the first one might load a bit faster, the second one feels faster. I kind of do this on my portfolio. So this is how my portfolio loads. So you see nothing, then you see the name, and then you see the stars popping up, and then you see the shooting star. Now, technically, I'm loading the stars slower, but it gives a better experience to consumers when you're loading things this way. Fun fact about this particular example is if I go to the page speed score of this, you actually see the speed index is in yellow. It's not green. The thing is, because stars are loading slower, it thinks that things are still loading, and it kind of punishes me for that. But even though the score is low, the loading experience is better in this case. So there might be few scenarios where your performance score might give you some different hint, but you just have to take a call based on what your user experience, what is the user experience that you want to provide. One more example I had was something that I do at my documentation site for Abel. I have this live code editor. So far, we talked about, even perceived performance, we talked about more in the context of the loading experience. But it is also experience of, in general, using things, using interactive things. Here, you see that I have an example, which is a live code editor. But if I refresh this page, you see the output is loading immediately. How is it loading immediately? It didn't even run the code. It didn't install the dependencies. How does it know what to output? But if I click here, you see this initiating web container installing dependencies. Starting dev server. I had another one open. Just open an incognito. Here you saw a flash of content. Now if I go and edit, it actually becomes a live code editor. Now, how do I magically know what is the output? The answer is I define it. In code, I am the one who's defining the examples code, so I also know what is the output. So when I'm defining the actual code, I also define the output, which acts as a placeholder until the time your actual code runs and installs dependencies and actually shows the output. And this is what I do with all the examples. So even the larger examples you see, it shows some content, but I can't really go and edit it. When I try to edit, it just starts initiating the web container. And I kind of handle some of these cases where, let's say I'm typing here. It's not changing, but once it loads. Yeah, once it loads, it just starts from there itself. So it's not just about loading experience, it's just about experience in general when people are interactive with things. I showed this definition of perceived performance. There are some issues. One thing is perceived performance is subjective. So there's no objective way to measure and score the perceived performance. It's also harder to quantify and measure. So there's no tool that just measures the perceived performance as such. There are tools that gives you hints on what might be the issue. For example, you might see LCP in the page speed, which will give you a hint that the largest image is loading slow. But that's a hint. That's not the source of truth. So how do you debug perceived performance if it's subjective and if it's not measurable? The answer is there's a mental model for debugging. You have to think of it from perspective of user. For example, first question that you should ask yourself is, what do you want to load in the first render? In a landing page context, I want to load my title, my CTAs, and some of the initial important things. In dashboard, I want to load the side nav and the top nav. The content can actually go and make an API call, get the user data, but side nav and top nav, if it's static, it should load at the first render itself. In the code editor, the mark that I had for myself was I want to load the output as soon as possible. I don't want to show the loading and installing dependencies if someone is landing on the landing page, because a lot of people might not even wait till then. People would just scroll through and want to see the output and inputs. Second question you ask is, where is it in the network waterfall? The thing that you want to load first, where exactly is it in the network waterfall? For example, in this live code editor, if I had not statically defined the output, it would load this way, where initially it will just show a loading screen, and then eventually it will show the output. But if I want to show the output, you have to understand that it's part of the network waterfall, so I can't really show the output first. So one advice of perceived performance is fake it until you make it. It's a horrible life advice, but it really works with perceived performance in a way, where you just pretend your site has loaded, or you pretend your site is loading, but you don't really load it, or you do some hacky things around depending on your context, and just make it look like it works. We did this with razorpay.com a few years back, and this was kind of the result. You obviously see that it's loading fast, but loading fast was not just the case. It loads better. You see a lot of jankiness in the first one, where a lot of things are just moving around. The first top bar is just coming from in between, and then it shifts. It loads a bit slower. And in this case, everything is just placed where it is, and it also loads fast. These were some of the network waterfall issues and some perceived performance issues, some CLS issues, which we fixed. And yeah, that's it. Thank you. I'm Saurabh, so you can check out my GitHub and Twitter.